Welcome to the Edge of Engineering, where curiosity meets innovation. Let's explore the technology shaping our world. The resistor, capacitor, and inductor are the three fundamental building blocks of electricity and electronics. And in this video, we'll focus on one of them, the resistor. We'll explore what a resistor is, the fundamental equations that describe its behavior, where resistors are used in everyday life, how they behave in an electrical circuit, and why they are so important in modern electronics. So, let's dive in and discover how this simple component makes today's technology possible. First, let's understand what a resistor actually is. A resistor is one of the most fundamental components in electronics. Its primary function is to oppose the flow of electric current and control how much current can pass through a circuit. Resistors are passive components, which means they do not generate energy. Instead, they dissipate electrical energy in the form of heat. They are available in many different shapes and sizes, but they all serve the same purpose, controlling and limiting current. The electrical resistance of a resistor is measured in ohms, represented by the Greek letter omega. From simple LED circuits to complex computers and electric vehicles, resistors are essential components found in almost every electronic device around us. Now that we understand what a resistor is, let's take a look at the fundamental equations that describe its behavior. To understand how resistors behave in a circuit, we need to look at their fundamental equations. The most important relationship is Ohm's law, which states that voltage is equal to current multiplied by resistance. Resistors also dissipate electrical energy in the form of heat, and this can be described using the power equations shown here. These equations are the foundation of circuit analysis and are widely used in electrical and electronic engineering. Resistors are among the most widely used components in electronics and can be found in almost every device we use in our daily lives. Whether it's a smartphone, a laptop, a television, a power supply, or even an electric vehicle, resistors are working behind the scenes to ensure these systems operate properly. Their primary role is to control the flow of electric current, protect sensitive components, and maintain stable operation within electronic circuits. In lighting systems, resistors are used to limit the current flowing through LEDs. In power supplies, they help regulate voltage and improve circuit performance. In electric vehicles, thousands of resistors are integrated into control units and battery management systems. Although they are small and simple components, resistors are essential building blocks of modern technology, making our everyday electronic devices safe, reliable, and efficient. Now that we understand what a resistor is and where it is used, let's take a closer look at how a resistor actually behaves inside an electrical circuit. As the name suggests, a resistor resists the flow of electric current. In other words, it limits how much current can pass through a circuit. This is one of its most important functions and is the reason why resistors are found in almost every electronic device. According to Ohm's law, the current flowing through a resistor depends on both the applied voltage and the resistance value. If the resistance increases, the current decreases. On the other hand, if the resistance decreases, more current is allowed to flow. Another important characteristic of resistors is that they create a voltage drop. When current passes through a resistor, a portion of the electrical energy is converted into heat. This means that the voltage at one side of the resistor will be different from the voltage at the other side. For this reason, resistors are often used to divide voltages and control electrical signals in circuits. Voltage divider circuits, sensor circuits, and many electronic control units rely on this principle. Unlike capacitors and inductors, resistors do not store energy. Instead, they dissipate electrical energy in the form of heat. This is why power resistors in high current applications are usually larger and sometimes equipped with heat sinks to improve cooling. Another interesting property of resistors is their linear relationship between voltage and current. As the voltage increases, the current increases proportionally. This behavior makes resistors predictable and easy to analyze, which is why they are considered one of the simplest and most fundamental components in electrical engineering. Whether it is a simple LED circuit, a smartphone, or an electric vehicle, resistors are continuously controlling current, producing voltage drops, and ensuring that electronic circuits operate safely and efficiently. Understanding how resistors behave in a circuit is essential because almost every electronic system depends on these simple yet incredibly important components. After understanding how resistors behave in electrical circuits, an important question remains. Why are resistors so important? Although resistors may appear to be simple components, they are absolutely essential for the operation of modern electronics. Without them, many of the devices we rely on every day simply would not function properly. One of the most important roles of a resistor is protecting electronic components. Many devices, such as LEDs, microcontrollers, and sensors, are designed to operate within specific current limits. Without resistors, excessive current could damage these sensitive components and even cause complete system failure. Resistors are also responsible for controlling current flow. By selecting the appropriate resistance value, engineers can determine exactly how much current is allowed to pass through a circuit. This ability is fundamental in designing safe and efficient electronic systems. Another important application of resistors is voltage division. In many circuits, different components require different voltage levels. Using resistor networks, engineers can create the required voltages for sensors, control units, and signal processing circuits. Resistors also play a significant role in filtering and signal conditioning. When combined with capacitors and inductors, resistors help eliminate noise, stabilize signals, and improve the performance of electronic systems. This principle is widely used in communication systems, audio devices, and power electronics. In addition, resistors are essential in measurement and sensing applications. Temperature sensors, light sensors, and many other electronic devices rely on changes in resistance to detect physical quantities and provide valuable information to control systems. Modern vehicles contain thousands of resistors distributed throughout their electronic control units. Smartphones, laptops, televisions, battery management systems, industrial machines, and power supplies all depend on resistors to operate safely and reliably. In fact, resistors are considered one of the fundamental building blocks of electronics. Together with capacitors and inductors, they form the foundation upon which modern technology is built. Despite their small size and simple appearance, resistors perform countless functions that make electronic systems more stable, efficient, and reliable. Without resistors, the world of electronics as we know it today simply would not exist. And that's why understanding resistors is the first step toward understanding the fascinating world of electrical and electronic engineering.